Good day. In today's video summary, we're going to look over Leaving Cert higher level trigonometry. So with trigonometry, there's going to be four key components we're going to look at today. The first of the four will be converting angle measure. We're quite familiar with degree measure from junior cycle, and what we've been introduced to has been radians. So what we've been told is that pi radians is the same as 180 degrees. So to convert from degrees to radians, we have to multiply by pi over 180, which would be 60 pi over 180, which will simplify to pi over 3. The second one is to work backwards, to work from convert from radians back to degrees. For that, we just let pi equal 180, so we sub in 180, and we would have had 3 times 180 divided by 2, which would have been 270 degrees. Okay, the second area of focus for trigonometry is trig equations, and before we look at trig equations, we're going to start with the unit circle. So the unit circle is, from the junior cycle, you would have looked at sine, cos and tan of angles in a right angle between 0 and 90. On the Leaving Cert, we're looking at angles of all measures, so angles between 0 and 360, as well as angles greater than 360 degrees. So, as we saw in junior cycle, both sine, cos and tan, all three in the first quadrant were positive. In the second quadrant, sine is the only positive, cos and tan will be negative. In the third quadrant, tan is positive, sine and cos is negative. And the fourth quadrant, cos is positive, sine and tan is negative. So that's the first thing we'll be looking at with the unit circle, and also whether they would be positive or negative. The second thing we would have had to look at is our reference angle. So what we need to do is find our reference angle in our first quadrant, and let's just say that that is theta. So if our angle was in the second quadrant, it would be 180 minus theta. If it's in the third quadrant, it's 180 plus theta. And in the last quadrant, it's 360 degrees. Take away theta in degrees. We could have also converted them all to radians as well. So if we had a general solution, okay, general solution is pretty much theta plus 360n. So if theta was 30 degrees plus 360, that's 390, would be the exact same place, and so on. So if you're given a trig equation where you're asked cos 3x equals root 3 over 2, you would have to, first of all, you'd have to find out what the reference angle is. Then you'll have to get two solutions. So each answer in the unit circle will have two solutions between 0 and 360. And because it's cos of 3x, you will actually have to have two solutions for the first 360, two solutions for the second 360, two solutions for the third 360. So you would have 6 solutions in total. Okay. Next stage we're going to look at is trig functions. So the two major functions we're going to look at is sine and cos. So we're going to start with sine 1x and cos 1x. We're going to look at how they're similar and how they are different. So sine 1x, like so, and a cos of 1x. Okay, look quite similar. The main difference is the sine of x will always start at the origin, okay, and the cos of 1x will start at the maximum value. In this case it's 0, 1, but if I had said 4 cos x, it would be the maximum value of the curve. Okay, so that's quite an introductory trig function that you need to have a good understanding of before we look at the more complicated of the trig functions that will be in the form a plus b sine cx or a plus b cos cx. A is what we'll always call is the midway line, here that the midway line would have been the origin, which would have been 0. Okay, B is what we call the amplitude or the stretch. So how far it's stretched, and C is with regards to period, which will be 2 pi over C is called a period. So as the period increases, or as the period increases, C would decrease, or as C would increase, the period would decrease. And then the range, okay, the range is going to be A minus B by A plus B. So it won't always be a minus 1 and a plus 1 and a minus 1. You could have a range of, let's say, plus 2 and minus 5. So you don't have to be correspond absolute values of each other. Then, so if we were to look at, let's go for sine of A plus B sine of Cx, the first thing you would have is the midway line is going to be A, and that is where we're going to start our graph. We're not going to start at 0, 0. We're going to start it at the midway line. And A plus B will be your maximum value, and A minus B is your minimum value. And go up. Okay, that's drawn. And then the period is where it goes before it starts to repeat itself. So that would be 2 pi over C, which would be your period. Okay. And the last thing we're going to look at is solving angles and sides using trigonometry. So you would have seen Pythagoras and SOHCAHTOA in junior cycle. They are related to right angle triangles only, and yes, you will be required to use SOHCAHTOA, use Pythagoras in trigonometric questions. So the first question you ask yourself, is the triangle I'm involved with, working with, is it right angled or is it non-right angled? So if it's non-right angled, we will have to use either the sine rule or the cosine rule. If we have a question, okay, we might have two sides, one angle, and we need to find a second angle. We would use the sine rule, which is A over sine A equals B over sine B. And if the question has given you three sides, A, B and C, and you need to find an angle opposite one of the sides, or you're given two sides, an angle, and you need to find a third remaining side opposite that angle, you would use the cosine rule, which is A squared equals B squared plus C squared minus 2BC cos A.